Okay, so last time we used the integration by parts formula to integrate an expression of the form x to a power times log of x, and we noticed that letting u equal the natural log of x actually worked for us. So now I would like to illustrate that if I have x to a power times either sine, cosine, or e to the x, letting u equal x to the power will actually work out for us. So let's look at an example. So how about x times sine x to give you the simplest possible one. So here my n is equal to 1. And we're going to let u be the x to the power, x to the first power. And then dv has to be whatever else is left over. That would be sine x times dx in this case. And now let's see, we need the formula. So we need u, v, and du. We have u. We can use this to get v. We can use u to get du. So du over dx is 1. du will be dx in this case. V will be an antiderivative for sine x. It's minus cosine x. Now we have all the pieces that we need. So this original integral becomes u times v, that's negative x cosine x, minus the integral of v times du. So negative cosine of x, du is dx. Okay, so this negative sign is really a constant multiple of negative 1 that we can pull out in front. Negative 1 times negative 1 becomes positive 1, so this is really plus the integral of cosine x. And now we can finish it off by computing this definite integral. Now keep in mind that as long as this is an integral that we can actually compute, then our choice of u and dv is working out well for us. And we have a solution. Now, it is worth noting that if I choose a higher value of n, for example x squared or x to the third, I'm going to have to repeat this procedure more than once. If I started with x squared sine x here, after the first integration by parts step, this integral is going to have x to the first power times the trig function. I'll need to repeat it. So let me illustrate that with another example.